surface, rough surface. I'll apply a horizontal force which will vary with the time like this. The normal reaction N, the weight mg, the friction force will be acting at this point. The friction by the block on the ground, this is the friction by the ground on the block. Let me assume some values. Mu s equal to say 0.5, mu k will be 0.2. Then what is the maximum, what is the kinetic friction? Already we have a formula, no? How to calculate kinetic friction. Kinetic friction is given by Fk equal to mu k into N. Mu k is how much? Before that, normal reaction. What is the normal reaction? N minus mg equals 0. So what is value of this? N will be N minus 3 into 10. So N equal to 30 Newton. And then let's come for Fk. What is Fk? Fk is given by mu k N. So mu k value is how much? 0.2 into 30. This will be 6 Newton. Limiting friction, this will be mu s into N. So mu s value, the maximum static friction it is 0.5 into 3, or this is 30, no? 3 5 ja 15 Newton. Okay, this is about the thing. So let me take it 3T in terms of this one. So let's go for a tabular column. There's a very basic thing which will really help you to understand the concept. Just only instead of speaking theoretically, I'm taking one example itself. Okay, this is a time. We'll take this column for time. This in seconds. Then this will be an applied force in Newton. And this will be the frictional force, Newton. And here we'll put acceleration of the block. And here the block. What will happen to the block? Okay, fine. So let's make out one by one. At t equal to 0, what is the force acting on the block? At t equals 0, what is the force acting on the block? So now here, when the block will shift, the block, and there's a theoretical idea again I'm bringing, the block shifts when F greater than equal to FL or greater than FL. That one. What is the FL? FL is a limiting friction. What do you mean by limiting friction? The maximum static friction is what? Limiting friction. So there's earlier we discussed static friction. Here, let me introduce that idea of the limiting friction. So maximum static friction is called as limiting friction here. So when the block will get displaced, when the applied force, the block shifts, you write it. The block shifts when F greater than FL. Or when it's about to shift, when F equal to FL. Got this? So therefore now, let's come for it. T equals 0, I applied a force. Then what is the applied force? Will be 0. So there's no applied force. Then no what happened, frictional force will act here. Then acceleration 0. What is the state of block? It's at rest. Then t equal to 1 second. What is the applied force? Applied force will be 3 Newton. Then come for frictional force. Then what is the, when the block will shift? Only when applied force is greater than limiting friction. Limiting friction is how much? 15 Newton. Try to see the limiting friction 50 Newton. But what is applied force? 3 Newton. So 3 Newton, can it overcome 50 Newton? Not possible. So therefore here, how much of friction? The friction will adjust itself. It's a self-adjusting force. So when applied force 3 Newton, the friction force will adjust itself to 3 Newton. So then how much it will be? It will be acting here 3. Then what is the acceleration of the block? Will be 0. And what is the state of block? Will be at rest. So let me take 2, 3, 4, 5 till 4. Now, what is the applied force? Let me put it 6 Newton, 9 Newton, 12 Newton, 15 Newton. Let's analyze. Let's analyze for the friction here now. Okay, I think I magnified it. So try to view it clearly. This is the core idea of friction. Today, I think your friction chapter will get over with this. That's what I feel. You can directly enter into starting numericals. Let's come for the friction. Now, when the block will shift, when applied force is less than limiting, no? When applied force is greater than limiting. What is applied force now for the second case? F equal to T equal to F equals 6 Newton. Then how much of frictional force? As the applied force is less than limiting, so what will happen? The friction will adjust itself to one value equal to how much? Equal to applied force as it is a static friction. So here how much will get? It will adjust itself to 6 Newton. And what is the nature? Static friction it is. Then when applied force is 9 Newton, then still the applied force is less than limiting. So when the block will shift? Only when applied force is greater than limiting friction. So therefore now the applied force less than limiting. What is the state of block? Block will be at rest. Then what is the friction acting? When block is at rest, the friction acting is what we'll call static, time being in the definition. So therefore here it will adjust itself to 9 Newton. Then this will be 12. Here what will happen? The limiting friction will come. So what is the state of block? Till here it was at rest. I'll call this particular state as motion impending. No, this 15 Newton is very important. I'll give some other color. And what is acceleration? 0, 0. This is also 0. Motion impending and rest means when applied force, you wait. I'll explain everything, Mile. I'll explain all the terms. At least you have to give teacher some time for 2, 3 minutes, at least 1 minute. No. Okay, what is this? When applied force is 15 Newton. When applied force is 15 Newton. So what is the friction force? Will become equal to limiting. So what is the maximum static friction that will act? It is called as a limiting friction. So now terms are there. Already you know mu k. What is mu k? Coefficient of kinetic friction. Now similarly, let me introduce what is mu s and mu k. Once again, I'll put it. Mu s is coefficient of static friction. Mu k is called as coefficient of kinetic friction. It is. Okay, now you try to see this. So when we apply force, no need of asking any question. In the end, I'll give opportunity to everyone. I'll say that concept over. Then immediately you can clarify your doubt because you are now learning stage. First, you carefully analyze teacher because I'm speaking so many important things. So just focus on my voice, understand, analyze. At the end, what happened? I'll tell you. Okay, fine. Any doubt? So you can clarify doubt. This will be the best procedure because otherwise, instead of what I'm telling, instead of that, what happened? You are getting deviated. The core ideas you may miss. Okay, let's come for that. Quotient of static friction, quotient of kinetic friction. So these two values can be same for a given pair of surface, or mu s should be greater than mu k or equal to mu k, but mu s cannot be less than mu k. Any reasons, sir, why you are taking the values here? What is mu s? It is like the interaction when the two surfaces are attached, when there's no relative motion between surfaces. Definitely the molecules will interact with more. So mu s will be more value. Then what do you mean by mu k? Coefficient of kinetic friction. When there's relative motion between surfaces, when there's a relative motion between, the interaction will slightly decrease. That's why the mu k will be less. There is a possibility, a situation where mu s equal to mu k. Means when there's two surfaces, when there's no relative motion between surfaces or the relative motion, the interaction will be same. In that case, mu s will become equal to mu k. But nowhere mu s will be less than mu k, or mu k will be greater than mu s. No, we don't have any situation till now. So mu s can be greater than or equal to mu k. It all like if there's no relative motion, the interaction will be more, mu s will be greater than mu k. If there's relative motion, then what happen? The interaction will slightly decrease. So mu s will happen will be greater than mu k. So in some cases, or mu s will be, or mu k will be less than mu s. In some cases, what will happen? When there's no relative motion or relative motion between surface, the interaction remains same. In that case, what happens? Mu s equal to mu k will write. It all depends upon the type of surfaces again. But we'll never get any pair of surface where mu s less than mu k. All of you got it? There's a one basic idea of mu s mu k. The mu s mu k depends on what? The type of interaction again. The wood glass will have one mu s mu k value. The wood and rubber will have one mu s and mu k. There can be some pair of surface where mu s equal to mu k. Yes, it can happen. So, and sometimes you see that as we proceed numericals, no, we do write mu s equal to mu k, because for some pair of surfaces, almost the difference is very less. So in the problem, they just write only mu. So what you have to understand that one is both mu s and mu k. Got it? No? Okay, let's come for the thing. Motion impending means, what is a motion impending? The block is about to move. It's called like a impending. I think the word English language, all of you are English medium. Pending, impending. Okay, try to correlate with your grammar, what you studied. All of you are from almost the best schools. So the basic grammar you should apply here. So what do you mean by pending? Pending means not moving. Impending means about to move. So about to take place, motion about to take place. The meaning of motion impending here. So now, as long as applied force is less than limiting friction. So what is the state of block? It will be at rest. Got it? It will be at rest here. Then what about the friction? The friction acting is a static friction. The friction acting is a static friction. And the static friction, we know, it varies as that of applied force. The limiting friction is called as a static friction only. Now, slightly will change the definition of static friction. Static friction depends on applied force as long as applied force less than limiting. Will I agree? When static friction becomes equal to limiting friction, then the limiting friction depends on normal reaction also. You see that one. The limiting friction depends on what? Depends on normal reaction. And the limiting friction is called as maximum static friction. I'm changing things. 0 to 14.99 Newton, the frictional force is a static friction. The limiting friction is also a static friction. But there's a differences there. The limiting friction depends on what? Depends on the normal reaction. The maximum static friction is called a limiting friction, depends on normal reaction. And the static friction less than limiting is independent of normal reaction. You can see that. The static friction depends on what? Depends on applied force. Then the limiting friction depends on what? Depends on the normal reaction. So therefore, static friction depends on applied force, S. Static friction depends on normal reaction, S. But as long as the applied force less than limiting friction, the static friction is independent of normal reaction. I'm trying to correct that particular the definition. Here the static friction you split up into two types. One, the static friction which is acting less than limiting. So what is that value? Independent of normal reaction depends on applied force. Okay, got this? The maximum static friction is called as the limiting friction. The value of that depends on normal reaction. Got the idea now? So when the block will shift, when the applied force becomes greater than limiting friction, this is the idea. Then the block will start shifting. So then here we got an idea, that one like this. And now, so let's t equal to 6 seconds, what will happen? Let's see that. T equal to 6 seconds I'm taking. What is the applied force? 18 Newton. Then what friction will act? There's a relative motion because the applied force is greater than limiting friction. The applied force is now greater than limiting friction, you check it. Then what when the block will start accelerates. So as it accelerates, then now what is the expression for acceleration? Acceleration is equal to F minus Fk by m. What is the applied force? Will be 3t. What is the kinetic friction? 6. What is the mass of the block? 3. So this will become t minus 2. We put acceleration. Okay, let's come for what friction will act, because the applied force is greater than limiting friction. The friction acting will be kinetic. How much kinetic friction? 6 Newton. Try to see this. This will be 6 Newton. What is the acceleration? T equal to 6, you substitute. 6 minus 2 will be 4. The acceleration will be 4 meter per second square. And what is the state of the block? In motion. Then 7 will take the 7. Applied force will be how much? 21 Newton. Then how much of friction will be? 6 Newton. Then acceleration will be 5. The motion of the block, it will be moving. 8. This will be 24. This will be 6. This will be, acceleration is t equal to how much later? It will be 6. This will be motion. 9, 27. Like that, you till 10 will put it. So this will be 30 Newton, 6 Newton. This will be 8. And the tabular column is what the total concept, rather than just speaking like some language classes. No, here I had to give a best method. The tabular column, it shows, it speaks a lot of things. So let's come for that one. So what is it? Look at the nature of friction here. Okay, let's come for this one. Look at the nature of friction here. The friction is increasing, no? 0, 3, 6, 9, 12, 15. Look at the applied force, it is also increasing. So how the friction force is varying here. Look at these two columns. Add that of applied force, because it's a static friction. Got this? So what is the nature of friction? This will be static. Then this is the here limiting friction will act. Then again, look at this friction. Though applied force increases, but look at the friction force. It's a constant, no? So what is this friction? Kinetic friction. So shall I say kinetic friction independent of applied force? Agreed? The kinetic friction is independent of applied force. Static friction depends on applied force. Answer, kinetic friction then depends on what? Depends on normal reaction. The static friction depends on applied force. S. Static friction depends also on normal reaction. S. When it is limiting friction. So limiting friction is also what is the static friction. Maximum static friction is called as limiting friction. So therefore, shall we break up this into 3 parts rather than saying only 2? Static friction, limiting friction, kinetic friction, for our convenient. Books didn't say it like that. Books, what they said is, books they just put static and kinetic. But for our convenient, we'll break up into 3 parts. Static friction, limiting friction, kinetic friction. Static friction now varies applied force independent of normal reaction. Limiting friction is also static friction. So limiting friction depends on what? Depends on normal reaction. Okay, got it? So till as long as applied force less than limiting, the friction acting is static, which is independent of normal reaction, depends on applied force. When the applied force becomes equal to limiting friction, the limiting friction is the static friction. Now it depends on normal reaction. Got it now? And then come for kinetic friction. Independent of applied force, but depends on the normal reaction. So therefore, I suggest you students to break up into 3 parts. Better will be on safer side. So this particular thing is, this what the happens here. So sir, like a really such a thing happens in real world. As you do one thing, take some, so like a some block, or sir, what do you mean block? You do one thing, take bag, your school bag, fill up some objects, like some stones you fill up, some boulders you fill up, some 5 kg, 10 kg, keep it in some grass, some in grass something, try to pull, then bring that and keep it in your floor, marble, granite floor, or tile floor is there, where you can pull the object very easily. On the marble or granite or the tile floor, no? There, because what happens, the surface is smooth. Then the same object, what happens, the same school bag with some stones of 10 kg, 15 kg, you try to drag the bag in the grass. You find difficult. Any reason for that? There the friction is more. And you do one thing, keep that bag on the grass, try to pull with a small force. The bag will not move. You keep on increase force. At one specific value, it starts moving. So some students, what they're doing is they're keeping on glass or on the tile or marble. They're keeping some objects. Sir, the moment I give push, it's moving. I didn't see static friction. I think the surface should be rough enough, no, to notice that static friction. So you keep that. You can try this. Really, I'm telling this one. You must go work out practically once. It's good actually, that one. Sir, I know already we have taken coaching and we are very good. I solved almost all problems, but you go once, see the things. You change the direction of force. You can see so many parameters will come into picture. Apply force horizontally. Instead of pulling, you push it. The things are totally different and very random. You'll be surprised that, oh, so many things I didn't observe. Now try to pull it. Pull and try to push it also. So got this one. So when you keep that bag on the grass, on the rough surface, and try to pull, no, initially it will not move. As you keep on increase force, still it will not shift. And one specific value, it starts shifting. Then as you further increase the force, it will start moving. So when it is moving, kinetic friction. When it is not moving, what happens? It will be static friction. Now this particular thing, everything, no, instead of this tabular column, I'll summarize in graph. Let me plot 2 graphs. One, this is the frictional force or applied force, and this is the time in seconds. So we have time 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The force value. So what are the forces that will be applied force? So maximum it came to 30 Newton. No? Let me take this is a 5. 15. 15, 20, 25, and this is 30. Okay, these are the thing now. So let me assume. So let me plot the graph. Applied force as well as the frictional force, both. These are the forces acting on block, both friction as well as everything. I'm showing it here now. Let's come for the graph one. Okay, let's come for graph one. So look at the applied force. It will just keep on increase with time. No? So the graph one, I'll take the applied force green color, 0 to 30. So this will be 30. The point will come here. Okay, fine. So this is the applied force. The green color is the applied force. No, what about the friction? We'll plot the friction. Initially, how the friction? The friction will vary as that of applied force till what? Till 0 to till 5 seconds. Till 5 seconds, the friction will be. Actually, it will overlap. Actually, it should be overlap. I to show two forces, no, that one. Then afterwards will become 6 Newton. I think I had to show overlap only. Fine now. Getting this method. So this what happens with the applied force and the friction, that one. So though applied force is increasing. So what is this? This is the applied force F. And what about this? This will be the static friction. And this is kinetic friction. Look at this, kinetic friction is independent of applied force. So let me plot another graph showing both the applied force with the friction. There's a nature of, this will be the friction, this will be the applied force. Anybody how the graph as I can plot between them, because you look at the second and third column. So the graph will be, the corresponding graph will be. This is what the limiting friction. This is what the applied force. So what is this graph? Friction, and this is the applied force. Okay, look at this. I'm very much interested in this. The static friction varies as that of applied force. So what is this value I should write? Anybody? So what I should write here? This, when the applied force becomes equal to limiting friction, both FL should come here. FL should be there, both the axes here. So come for this. And the applied force is less than limiting friction. Look at this x-axis applied force. So what is the friction? The friction will be less than limiting and will be static. Once the applied force becomes greater than FL, look at the friction value. From limiting, it will become kinetic. So here the Fk will come here. Look at this variation of graph. Some books open this particular graph on the surface. The shift what will happen from point A to B. Some books they're given like this. So for some surfaces it will be like this. For some surfaces it'll come like this, and for some surfaces it'll be like this. So it all depends upon the pair of surface. The transition from the static to kinetic will happen. The graph will happen. The curve will be different for different surfaces here. Got the idea? It'll be different for different surface. And for some surface, what happen? There won't be transition. The limiting friction, what happen, will become equal to kinetic friction. So the graph, what happen, will be it will continue here. So this gap AB, the gap, what happen, it depends upon the mu S and mu K. For different pair of surfaces, the gap, what happen, the A and B may overlap. The A and B will be large, and the transition curve will be different for different surfaces. So in SURM also, yes, instead of going for the curve, no, it has shown a dotted line, because you can't generalize. The curve should be like this one for different pair of surface. the transition, what happened, will be of different shape. I'm making clear. Got that, you know? So this is about the overall picture about the static friction and the kinetic friction. Anybody, if you want, you have a doubt, you clarify it. Huh?
Sir,
Yeah.
sir, please can you once again say how limiting friction is related to normal, sir? You gave an example.
That is a theoretically, there is a practically value. There is a practically what happened. They checked it. The limit in the maximum friction is what depends upon the n and mu s like that. Huh?
Okay, sir. Yes, thank you.
Uh,
Sir, sir, in
yes.
HCV, a statement about kinetic friction is given as once the bodies slip on each other, the frictional force is mu k n, whatever be the speed. This is approximately true for relative speeds not too large. Speeds should be less than 10 meter per second. Why is that, sir? I mean, why is that condition for speed
So,
given?
just give me repeat sentence once.
The
Repeat the
kinetic,
sentence.
yes, yes, sir.
I'll write.
Once the bodies slip on each other, the
Well,
friction
I'll write it. Once the
bodies slip on each other,
slips on each other.
the frictional force
Yeah.
is mu k n,
There's a kinetic friction. Yeah.
whatever be the speed.
What will be the?
Speed.
There's a relative something you said 10 meter per second something.
Yes, sir. This is approximately true for relative speeds not too large. Speeds should be less than 10 meter per second.
So, shall I write for the sentence? This is
Approximately true for
approximately true for
relative speeds
relative speeds.
not too large.
The 10 meter something you said.
Yes, sir. The condition is relative speeds should be less than 10 meter per second.
Relative speed should be. Okay. There is some practical based. We don't have anything. 10 meter per second. You convert this into kilometers per hour. 10 this will be. So shall I do one thing? 1000. Here 1000 is there. Because we'll get because kilometer per hour means because we do ride bike, no, it'll be much easy for us. 10 meter per second. So I'll bring 1000. This will be 3600. This will become kilometer per hour. Okay, fine.
36 kilometer per hour, sir.
36 kilometer per hour. This is the relative motion between the surfaces. So when the object is moving with 36 kilometer per hour, I think this is not something very big speed, no, not like something 200, 300. Even 36 kilometer per hour, the interaction between, so here first you look at this sentence. It's when the body slips on each other, the frictional force is mu k n. It's telling it's a relative motion. Whatever be the speed, as it's correct. Because irrespective of speed, what they'll have some interaction. But now let's come for the upper limit of speed. For relative speed, not too large. If the speed becomes more than 36 kilometer per hour, then the interaction, the molecular interaction, what happens, slightly will change. Due to that, what happens, this equation no longer will be valid. Valid in sense, we have to bring some other modified equation. So that's why he has put a condition. So definitely, I think when we are discussing any problem, we have to see that the speed should not be more than that. But I think nobody has taken care of this condition in numericals. I'm very sure. Even in SEORMA, there are some numericals are there where the relative speed is more than 10 meter per second. Still, we are writing this equation.
Yes, sir.
But it happens. Even in SEORMA, there are numericals are there. Even in Resnick and Dalde. This is something practical condition. Since we don't bother about anything practical conditions, no. So in our numericals, we don't bother the speed. Even object moving 20 meter per second, we still will apply the formula. But it should be a modified one. According to quantum mechanics, the things will change a little bit and we have to modify it. So the reason for that, what all numericals came, it was before the modern atomic structure. After 1920, what happened? We entered into modern atomic structure. Then with the help of the research, what happened? They came to know that as this particular thing. But what all the friction, everything, what we designed, the curriculum, everything, all the content, all the numericals, it was prior to 19th century. Therefore, the numerical what happened? We don't have the correction parameter. Got it? So here the problem for everything is the modern atomic structure came from 1920 onwards, or better say from 1930 onwards, we are in better picture. But by the time almost open, we have a better picture of friction. There's a one exceptional case what you can put it, but we don't bother to consider this case in your numerical. Even in advanced exam also, you need not to bother this situation. I'm making clear because there's a modern view, and what all we are discussing or physics is keeping the atomic structure prior to 19th century. Okay, got it? I'm making things clearer.
Yes, sir.
Yes, somebody still?
Sir,
Yeah.
sir, we are not considering this case as a 10 meter per second relative speed.
Yeah, you not to bother.
Yes,
Just
sir.
leave this.
But if we were to consider, how would we modify this equation, sir?
Modified equation depends upon the quantum mechanics. Still, you don't know properly mechanics, you know to bother. Okay.
Okay.
If I say one thing, if with the syllabus were there, I would have put it. Leave that one. Okay, come for this. Somebody, the friction, okay, share the screen. Friction depends on what? So it's independent of area of contact, no? I'll give example now. Still anybody having doubt, please clarify. I'll proceed to the next idea. Okay, fine. This graph, everything. Shall I go for next one?
Sir?
Yeah.
Sir, won't the block also have a surface which has some friction coefficient?
I don't know why you are not understanding the definitions I put. The quotient of friction depends on pair of surface.